So now we have our first two components on the board, and we're going to move on to the second most common, or the second component I recommend to put on your boards, and that is anything that is extremely difficult, but is also low profile. So in low profile, I mean in regards to height off of the board. Like these two components are very low profile. They're very flat to the board. This component here, U2, is a perfect example of something that is extremely difficult to solder by hand, especially with these vias really close to these pads in some of these spots. I want to do these components before I do all the passives around it. Because if I were to do these passives first and then attempt to do U2, I would have a lot of trouble getting at these pins accurately with my soldering iron with all of these passive components here. So the first component you want to do are QFN components, which now I have all of them done. The second component you want to do is very difficult low profile components. You do not want to do high profile components yet. Those can be done later. So yeah, I'm going to pause and I'll be back with U2. All right, here I am back. This is U2. It is an FT4232 USB to serial adapter. This component is used to connect a single USB port to up to 4 serial devices simultaneously. This package, this square flat component with many legs on all sides, is called an LQFP package. Any component, including this one, which has fewer pins, is also LQFP. LQFP is always a square component with equal legs on all sides, unless it is an abnormal version of LQFP. This particular one has 64 pins, making it an LQFP64 is the name of this package. So now we're going to go ahead and I'm going to teach you how to solder an LQFP64 package. And the way I like to do that is to remove the component from the pads first. And I will put a tiny amount of solder on 4-ish pads. I need to turn up the temperature on my soldering iron. On 4 of these pads. And then I will move the component back onto the pads. I will then connect it to those pads one by one. And once it's connected to 4 pads, it will be held in place. And from there, I can solder every single other pin. So any multiple pin component, in fact, any component in general, what I will typically do is do very few solder joints, just enough to hold it in place. And then once it's held in place by its solder joints, I will solder the rest of the pins. So we're going to go ahead and get started. I'm going to start with pin 1 over here, denoted with this dot. And these can be a bit tricky. See, now you just saw how a ball kind of formed on the tip of my solder. That is bad. If I were to have attempted to solder this pin, there we go, that's the behavior I want. See, now I have a bit of solder on that pin. It's hard to tell from the camera, but there is a little bit of solder on that pin now. It does have a bubble of solder on it, and that's exactly what I want. I'll rotate 90 degrees. I'm going to do it again here. I'm going to get every corner pin. Now, in general, the pin that I will solder to, just to hold the component in place, will usually be the most accessible pin. Because finagling the component perfectly straight while trying to solder it is difficult. And I want to make the process, there we are, as easy as possible. So, since this is the hardest part of the process, I might as well do it with the easiest pads to cancel that out. So there we are. Now we have all 4 of those pins covered in solder. Now, for any of these extremely difficult components, like this LQFP64 package here, flux is going to be your best friend. Now, unfortunately, my really nice flux isn't accessible to me, so I have to use some of these crappy flux pens that I have left over that are almost completely dry. So I'm just going to cover all these pads in as much flux as I can. Flux is definitely going to be your best friend on this component. And then on the component itself, I will also cover all the pins in flux. We want as much flux as possible in these connections to help prevent bridging. Now on a component that's being done by hand that has such tiny pins like this, bridging is essentially inevitable, especially if you're new to SMD soldering. I'm sorry for my gross fingernails. Especially if you're new to SMD soldering. So, hit this side one more time. Yeah, there we go. The flux is also going to act a little bit like a glue and help hold the component in place while I am soldering. I just realized I haven't turned my heat gun off. I'll turn that off. Okay, so here's our component. Here's our pad. I'll take the component over to the pad and look into the microscope. I'm not using the same visual as you. I'm looking into an optical microscope right now. And you want this component, especially because these pins are so close together, to be as accurately lined up as you possibly can. Definitely take your time on this part and do it right. You want there to be minimal rotation and minimal offset. So you can see these pins right here, all these side ones look okay. Actually, now that I've been moving the board around, they kind of got shifted. They don't look okay anymore. But these top pins definitely look horrible. So I definitely need to keep adjusting. There's that side. I'm going to move this bottom corner over here. And there we are. And then all I need is a tiny bit of movement in this top corner here to address a little bit of rotation I have left over. And that looks pretty dang perfect to me. Okay. So now I'm going to take my soldering iron. I'm at 325 degrees Celsius for this component. I'm going to take my tweezers. I'm going to try my best to hold the component down without shifting it. It rolled off of the pads. There we go. Oh, that looks good. That looks good. Okay, I am very happy with that. I have a tiny bit of offset. I'm going to adjust the other side. Oh, I actually have 2 LQFP64 components on this board. I'm going to show you guys how I did this one, and then I get to do a second take just in case I don't like how this turns out. Aha, I have one pad soldered in place, and the rest of the pins all look pretty dang good. So now that I only have one pad, I can still do a little bit of adjustment while that pad is held in place, as you can see. So I can do some more fine tuning as I do this second pad. Oof, that was not ideal. I can remelt this and adjust it, and there we go. Now the second pad is done. I did not like that joint though. I will come back and redo that joint once this component is held in place a little bit better. So we're going to do this pin here. Yeah, I like that. And then we are doing this bottom left pin here. And there we are. Okay, so now we have 4 pins, and if I push it with my fingers, this component no longer moves. It is held in place at 4 points. And as far as alignment, I think I did okay. I did not do great. Specifically on this left side here and this top side here. I'm going to go back to the original orientation that I was in. And there's the component. So this bottom side here and this right side are not perfect, but they are good enough to work with. I'm going to clean my soldering tip. Definitely going to want to keep that clean. And since I did the left pin, the way I'm going to do this is I'm going to work from, oh, I had a little gunk on the tip of my soldering iron. I'm going to work from the right to the left to the pin that I've already done. I'm going to add solder to all these pins, make connections, and then once I get back here, I will rework that joint that is currently only serving to hold the component in place. So again, this is usually done in an oven. Now this right here, I don't know if you guys can see that as well as I can in the optical microscope, but I have solder on the pin, but it is not on the pad. This is not a connection. It is only on the pin and not on the pad. And in fact, there's too much solder. I guarantee you this is going to bridge. Oh, it did not. I am awesome. So now it is soldered to the pad properly. And looks pretty good, actually. It was not nearly as much solder as I expected. So one way I like to do these is I like to put a little bit of solder on the tip of my soldering iron. So now I have a tiny bubble there. I'm going to flip my soldering iron over so the bubble is facing downwards towards the board. I'm just going to touch each pin. There we go, that's a connection. This is now a connection. This one is not connected. I ran out of solder, so I need to get a new bubble. Unless you're really enjoying this, you can probably skip ahead, because this is pretty much the rest of the work. I am just going to be soldering one pin after another and double checking. Oh, see, here we have a bridge. Don't skip ahead. I will be, once I finish this side, I will teach you how to take that bridge out, which is a very important skill for detailed components like this one. So I'm just going to go ahead and keep pressing on. We're going to leave that bridge for now. I think that's connected. I'm a little skeptical on these two here. One way you can test to see if these pins are properly connected, you can get your tweezers and you can fiddle with the top of them here. See how that pin wiggles a tiny bit? That means it is not properly connected. This one too. This one here does not wiggle at all. It is properly connected. But this one wiggles. And then this one wiggles. So they are not connected. Oh, that is ugly. As long as you don't have a cold joint and you have a connection, I recommend you leave well enough alone. Okay, these, you can see how it's creating tails in the solder, where it's kind of like it's stiffer and it kind of forms to shapes. It doesn't reflow down into the pins. This is because there's not enough flux or not enough heat. So what a lot of people will do is they compensate with heat. And they will add heat, and that makes the solder behave a little bit better, but also burns off your flux faster. So what I recommend doing, instead of just blasting your components with more heat, is to add flux. Then you can use the same heat. You don't have to burn through your flux. You get a better joint. And it makes rework easier in the future. So now I have more flux. This is really garbage flux, but there we go. Now it is behaving immaculately. No more tails. Perfectly blended into the pin. I have another ball. I'm going to turn 45 degrees. And just, oh, that's probably going to bridge. That's definitely going to bridge. Okay. Again, not enough flux. This is also old solder, so the flux inside of the solder is not great. It is good solder. It's Kester. Let's put some flux on there. And I'm going to teach you how to take out these bridges. So I have 4 bridges on this side, which is pretty bad. I'm definitely rusty. I'm going to show you how to deal with these. So what I like to do is I will take my solder wick. You can see I have solder globs all over this. I will cut it so that I have a fresh end. This is my garbage piece. And I have a fresh end on my solder wick. So what I do is I line up the end with the blob that I want. So I'm going to do this far right blob first. I'm going to press into the blob and hold the wick there. And if the wick does not heat up enough on its own, I will feed it a little bit of solder. Let's get a better angle on that solder. Oh, no, it's beginning to, feed it a little bit of solder. And as that solder soaks into the wick, as you can see, it will pull the solder from the component as well. And now I just run down and I get all of the bridges with the hot wick. And there we are, no bridges. It's just that easy. I have worked with people who have spent hours working on a single solder bridge on these components. But if you work with your solder wick and you feed it a little bit of solder so it can heat up thoroughly and evenly, you don't have to wrestle with it. So now I'm going to double check that all of these pins are properly soldered in and make sure none of them wiggle. I have a little bit of burnt flux on them, but that's okay. This one's good. I feel like oh, this one wiggles. In fact, I bent it out of place. So I'm going to bend it back into place because I didn't bend it very far. There we go. So this one needs to be redone. This one too. This one too. This one does not. So these 3 right here were never soldered to the pad. They only had solder on them. So now there's tons of flux here. This should be pretty easy. Oof, I just misaligned microscopes. Okay, there we go, we're aligned again. So, let's take a look at my tip. Let's see what I got to work with. I don't have any solder on my tip. Oh my god. My microscope lenses are now so misaligned. It's making me have to look through my microscope cross-eyed. Nice thing about an optical microscope with two lenses is you get to see things in 3D while you're working with them. Oh god, now I'm seeing... Damn it, I'm misaligning everything. Okay, that's good for alignment. And then now I gotta fix my double vision. There we go. Okay, now we're gonna go through these 3 pins. Okay. Clean up. I'm just gonna burn some solder on my tip. Just get some flux on there. Get something to work with. Make sure no solder balls fall on my part. And now I have solder, some leftover solder on my tip. There. That one has a tail. We'll deal with that in a minute. And that one's good. So to deal with the tail, again, just a little bit more flux. And then you just tap it with the soldering iron, and the tail should go away. And there we are. Double check these last 3 pins. That one's good. That one's good. And that one's good. All right, that's 16 pins done. 48 to go. All right, we're back. This is the final product after having soldered each pin on this component. These 3 sides, this side, and the bottom, took some work and some rework. I did have some bridges on those sides. I think I had 6 bridges overall. And then this top side went perfectly. No bridges, it only took me a couple minutes. Overall, the entire component took me a little bit over half an hour. Yeah, after I finished the component, I hit it with some isopropyl alcohol and a toothbrush just to clean off a majority of the flux. There is still some flux between the pins, but it is not visible with your eyes. Although it looks still pretty ugly in under the microscope, visually it looks very clean and it looks pretty good. Okay, so I wanted to demonstrate the capabilities of using flux for your soldering, which is sometimes difficult to get a hold of. Today I'm going to be using, it's hard to show under the microscope, but a large syringe of Amtech flux. This is a pretty high quality flux. It comes in a syringe and has to be kept refrigerated. Now I'm going to go ahead and spread some flux on this microcontroller here and show you what it's like to solder with a high quality flux and why I recommend doing so. So now that flux has been applied, look at what happens when I add my soldering iron. It turns into a liquid. Not only does it magnify what you're working on, but any joint within that liquid instantly becomes a high quality joint if you reheat it while submerged in flux. Excuse my shaky hands. Trying to avoid bridges, but soldering, the solder will flow a lot more predictably. It will become less viscous. Got a little bit of bridging here. And then desoldering will become significantly easier as well. Now you can see that the flux kind of boils as the soldering iron comes in contact with it. The smoke that comes from the soldering iron is actually mostly vaporized flux. Still not very good to inhale, but contrary to, I guess, popular belief, it doesn't have any lead in it. Still, I would try to avoid breathing the fumes. It might not be as cancerous as lead, but it certainly isn't good for you. Now the flux I'm using, solder on my tip. The flux I'm using is yellow. And when you buy high quality flux, it should come almost clear with maybe slight yellow hues to it. Can't get the solder on the right spot on my soldering iron. As the flux ages, it will turn more and more brown. If you buy brown flux, it tends to be of a lower quality. There we go. Now it's getting to the point where it's harder to see my individual connections. Let's see if I can get some shine from the side here. Now you can see I have 3 bridges. I'll demonstrate removing those bridges in the presence of flux. Now, once you put a lot of flux onto your board, it is a pretty sticky substance. You can wash it off with rubbing alcohol. And I recommend, just to get rid of the flux that was in the solder, as well as, there we go, as well as just like general tidiness. Once you are done making a surface mount PCB, make a 3-way bridge. At least now I know it's soldered. Once you're done soldering a surface mount PCB, I recommend you wash and scrub the whole thing in at least 70% rubbing alcohol to avoid stickiness or fluids on the board. So now I'm going to desolder. Oh, you can see how goopy it is. Ooh, that's fun. Now I'm going to desolder these bridges in the flux. And you can see that the heat spreads much more evenly in the flux. And I probably don't even need to add solder to my braid. Still not, there we go. Now it's absorbing the solder. There we go, this is desoldered. That one's desoldered. That one's desoldered. And now I'm going to test all of these connections to see if any of them wiggle. Nope. 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 No. Even though some of these look like they don't really have any solder on them, they're still connected because the solder becomes so fluid when you heat it up under flux that you can create connections that are smaller and still strong in solid connections. So for example, under this third pin here, there is solder probably coating the entire bottom face of this leg. Even though there is very little on the top, I absorbed it with the braid. And adding solder is also relatively simple with flux. The main point of flux, though, is that you can rework and work with your solder as much as you want, and you will not worsen the quality of the connection like you would if you were not using flux. The more you work your solder over and over again, the lower of a quality of connection you wind up with by the end. That is not the case under flux. So now you can see that is a much stronger connection. All my joints are shiny and smooth, which is exactly what I want.